Has anyone ever sat down, looked you straight in the eye and asked, has anyone ever shown you how to build a homemade welding machine, starting with nothing more than a key? If not, today might be the first time you hear a story like this. According to my plan, that key will serve as the welding tip. It will connect to the handle and securely hold the homemade welding tip, forming a simple yet stable setup that's ready to work. Next, I had an extra box filled with rivets. They're usually just small fasteners for metal parts, but to me they've always felt like more than that. And that's when the idea clicked. Using a rivet as a homemade welding tip could be a great solution. Compact, solid, and easy to work with. Sometimes the best ideas come from the most ordinary things. To secure the rivet into the hole of this key, I chose to use a rivet gun, which makes a lot of sense here. The key is applying just the right amount of force, enough to hold it firmly in place. Push it too far, and the rivet body may pull out completely, sending you back to square one. This wooden clothespin should look very familiar to you, right? It's a common household item, made of wood, lightweight, comfortable to hold, with a spring that's firm enough to be useful. Those simple features are exactly why I decided to repurpose it as a handle for this homemade welding device. And if you've followed me long enough, you already know, in DIY nothing is impossible. To securely fasten the key and rivet assembly to the wooden clothespin, I'll use 4 plastic zip ties to tighten everything together. It's a simple and quick solution, but strong enough to keep all the parts firmly in place during use. In my hand, I have a 2x4 electrical terminal block. I'll remove one connector from the block and use it to link the rivet shaft to the homemade welding tip, creating a neat and manageable connection point. For this DIY project, this type of electrical wire is more than enough. It can comfortably handle a small current, keeping the setup simple, neat, and without the need for thicker or more complicated wiring. To keep things from getting in the way while working, I'll secure a section of the electrical wire along the handle using tape. It helps keep everything neat, makes the grip more comfortable, and lets me focus on the task without distractions. After connecting one end of the electrical wire to the welding tip, I'll attach an alligator clip to the other end. This setup makes the connection more flexible and much more convenient during testing and use. This should come as no surprise. In most of my homemade welding tip videos, you'll almost always see this AA battery show up. To many people, it's just an everyday battery, something you use and then throw away. But for me, the real value lies on the inside. What truly matters is the carbon core. It's a surprisingly unique material, stable, heat-resistant, and able to conduct electricity at a very controlled level. It's not as aggressive as metal, but not so weak that it becomes useless either. That balance is exactly what makes carbon well suited for small DIY experiments. Another practical advantage of the AA battery's carbon core is its shape. It's slim, straight, and easy to work into simple homemade setups. When you hold it in your hand, it feels manageable and precise, not bulky, not overcomplicated. What I personally appreciate most is that once it's properly prepared, the carbon core can be used right away. No complex steps, no specialized equipment. And in the DIY world, simplicity often makes the difference between an idea that stays on paper and one that actually comes to life. That's why, over the years, the AA battery's carbon core has kept appearing again and again in my projects. Not because it's perfect, but because it's reliable, accessible, and practical. Qualities every DIY maker learns to value over time. So that's it, a homemade welding tip made from a battery core is now complete. Just one small thing to keep in mind: when installing the tip in its proper position, make sure to tighten the screw with moderate force. The battery core is quite brittle, and applying too much pressure can cause it to crumble, sending you back to square one. I'll make one more simple tool to connect to the negative terminal of the power source, just to complete the setup. Its structure is very straightforward: a length of electrical wire with alligator clips attached to both ends, making it flexible and easy to use. The power source I'm using for this setup is a small-sized battery. It's compact, easy to handle, yet more than capable of supplying enough power for a simple DIY project like this. When the positive and negative terminals make contact and an electric arc appears, that's a clear sign the device is working successfully. Next, I'll run 2 small tests so you can see for yourself how effective it really is. So if you're curious about the results, make sure you don't miss this part. The first test is pretty straightforward. When working with thin, lightweight metal, the device doesn't burn or distort it. Instead, it joins the pieces together firmly, exactly as intended. That's enough looking around. Now let's move on to example number 2. And as the saying goes, the reward always goes to those who stay until the end. In this part, I'll show you how soldering can be used to fix an LED bulb with a blown LED chip. This is a very common problem, yet most people don't know how to deal with it. So the bulb usually ends up in the trash, and that's where the real issue begins. Discarded LED bulbs don't just disappear. They add to electronic waste, which is already piling up faster than we can manage. Inside each bulb are electronic components and materials that don't break down easily, and when thrown away in large numbers, they quietly contribute to long-term environmental pollution. That's why learning to repair something as simple as a burned LED chip doesn't just save money, it also means one less bulb thrown away, and one small step toward reducing unnecessary waste. In fact, this isn't too difficult because with a careful look, you can usually spot exactly where the LED chip is failing. In most cases, the issue comes from a broken or poor electrical path on the chip, which prevents current from flowing properly. The idea behind the fix is to use solder to fill and reconnect the damaged area. Once applied correctly, the solder acts as a conductive bridge, allowing the current to flow again and restoring the bulb's function in a simple yet effective way. And with that, our journey of building this homemade welding machine comes to an end. From simple, everyday items, some of which might have been considered useless, we've managed to create something that actually works and does exactly what it's meant to do. What I want to share goes beyond this welding tool. It's really about how we look at the things around us. In DIY, creativity isn't defined by expensive tools, but by the willingness to observe, think differently, and try. Every old object has the potential to take on a new role, if we give it the chance. And sometimes with just a bit of patience and curiosity, you'll realize that the best solutions are already right in front of you. Thank you for staying until the end of the video. I'll see you again in the next DIY project, where things that seem impossible continue to become possible.